Okay, good evening. Alright, so today we move on to the next concept, okay, on measure dispersion. Okay, now let's say you're given a set of numbers, a data, a simple data like this. I've got 1, 2, 3, 4, 5, 6, 7. Okay, and we make some changes to this set of data. Okay, now what's going to happen? So these are the four measures or four quantities that we looked at under the measures of dispersion. Okay, so we'll start with the range. Range will be the largest minus the smallest value. So here I've got 8 and minus 3, so this will be a 5. Okay, for your interquartile range is Q3 minus Q1. This is my Q3. Okay, so if you remember, median is the value in the center. Then this is your first half. So in the first half, we look which is the value in the center. So that will represent Q1. And this is my second half. So the value in the center will be your Q3. Okay, so it's actually 7 minus 4, which gives me a 3. Okay, now we go for variance. So variance formula is bar squared over n. Okay, all right. So, or another option will be over n, be minus of the b. Okay, all right. So if I'm going to use this, so we need to add up summation of x. So you'll actually get, okay, so this is the sigma x squared. So each value is squared. So it's 9, 16, 25, this is 36, 49, 49, and the last one is 81, 64, sorry. So you get about 246 over 7. Okay, now we calculate the mean. Okay, the mean is we add up all and we divide it by 7. So it's 7, 18, and that's a 15. So it's actually 40 over 7. Okay, so when we actually work it out, so 40 divided by 7 and a square, you got to square it. Okay, so you get 246 over 7, the minus of the answer. Okay, so we get about 2.4. Just double check. So here I get 47 and you square it. Okay, so about 32 over 49. Okay, so it's 2, 6. Let's check it again. So this is 3. 9 plus 16 plus 25, 36, 49, 49, this is 64. Okay, so sorry, this is 248. Okay, divided by 7. Minus of this one. Okay, so we get about 238/49. Okay, I'll leave it as that. Okay, so that means now so this is actually 2.776. Okay, so my standard deviation sigma becomes square root of 2.776. So we get 1.666. Okay, so that's the value of the original number. Okay, this is your standard deviation, your variance, your range, and your interquartile range. Okay, now what happens if we add all this by 2? We add 2 to all the values. So meaning now your data is so this will be a 5, 6, 7, 8, 9, 9, and 10. Okay, so we'll calculate your range. Okay, so your range is the bigger value minus the biggest minus the smallest value. The 10 minus 5 is also a 5. My interquartile range, you've got 9 is your median, Q3, this is Q1, so it's again 9 minus 6, I get 3. Alright, okay, now for my variance, okay, variance is going to be all of this, we squared it, same formula, all of it squared, so when we square it all, we'll actually get 25, 36, 49, 64, 81, 81, and 100. So you'll actually get 4, 6, 3, 4, 3, 6 over 7. Okay, minus. Okay, now my mean is going to be, here I get 18 plus 17 plus another 19. So this is 54 over 7. Just double check. 11 plus 13. 28. Over 7 squared. So when we calculate this, squared. Okay, so we still get 2.776, and your standard deviation, okay, when you square root this, you still get 1.666. Okay, all right, range, interquartile range, variance, and standard deviation. Okay, so from here, what you can actually see is when you have an original set of data, this is my original set of data, and now what happens to the second one is I've actually added every data by 2. So that's how I got these values. So you realize that the measures of dispersion does not change, is not alter, it's still the same, the values are still the same. Okay, so this happens when you add or you subtract values uniformly to the entire set of data. So we realize that the measures of dispersion does not change. Thank you.